Hello students, and welcome to the second video of this four-part series. In this video, we're going to make an understanding of the trig functions. How can we find the derivative of the other trig functions? We started with just sine and cosine, and now we're going to find the additional four. So let's get started. So as we're doing this, we want to use the quotient rule that we just learned about in our previous video, where we want to use that tangent rule or that quotient rule to find some of these. So in order to do that, we're gonna have to write a lot of these functions. So tangent, cotangent, secant, cosecant. We're gonna want to write all of these as quotients that we can work with. For example, with tangent, we can rewrite this as sine of theta over cosine of theta. And now with that, I can find its derivative. So f prime of theta, and then that's where the quotient rule comes in. So cosine of theta times cosine of theta minus sine of theta, and then the derivative of cosine, that's negative sine of theta, square the denominator, so cosine squared theta. All right, and let's simplify this. Let's see what happens here. So I get cosine squared theta plus sine squared theta all over cosine squared theta. And that's a Pythagorean identity, and that's going to be helpful here. Cosine squared plus sine squared, that's going to get me 1. So I'm going to get 1 over cosine squared theta. And 1 over cosine squared theta, I can rewrite that. That's going to be secant squared theta. So let's rewrite this. If I want to find the derivative, or dd theta, if I want to find the derivative of tangent of theta, well, that's just going to come out to be secant squared theta. Add that to your arsenal because you're going to want to make sure that you remember that equation. Let's jump over to our second one. So again, cotangent is just a reciprocal of tangent. So that's going to be cosine theta over sine theta. Okay, and so if I want to find its derivative, let's see, all I've got to do is go sine theta times negative cosine, sorry, that's wrong, times negative sine theta minus cosine theta times cosine theta. Okay, square the denominator, and away we go. All right, so in my numerator, I get negative sine squared theta minus cosine squared theta all over sine squared theta. So this looks very similar. And what I'm going to do is I'm going to factor out a negative 1, and I'm going to get sine squared theta plus cosine squared theta right there. And now that's still divided by sine squared of theta. And so we know that sine squared plus cosine squared, that's 1. So I get this come out to be negative 1 over sine squared theta. And that's a reciprocal identity. And what I can do with that is get negative cosecant squared theta. So whenever I see the derivative dd theta of cotangent of theta, we know that that's going to come out to be the negative cosecant squared of theta. So now you don't have to go through all this work. You just want to have that one memorized. All right, so secant theta, I'm going to rewrite that as a reciprocal. So that's going to go to be 1 over cosine theta. And now I'm going to use that quotient rule that we've learned about. So f prime is going to be cosine theta times 0, so because the derivative of a constant 0, minus 1 times the derivative of cosine, so that's going to be times negative sine theta. Now I square the denominator, so cosine squared theta, and so cosine theta times 0, and then I get a negative times a positive, so I get positive sine theta over cosine squared theta. Now that doesn't look too good, so I'm actually going to rewrite that here real quick, and I'm going to rewrite that as 1 over cosine theta times sine theta over cosine theta. And the reason why I want to kind of rewrite that there is because 1 over cosine is secant theta, and sine over cosine is tangent theta. And that's a little bit easier for me to recognize instead of seeing all these other parts and squares. Where does that square go? So whenever I see the derivative of secant theta, I know that it's going to come out to secant tangent theta. So that's going to really help me fire that home about what, okay, so if I have the derivative of secant, that's secant tangent. Really easy to remember. All right, and I've got one more here. We're going to do it very similar way. So we're going to finish this one out, and that's 1 over sine theta for cosecant. So if I want to find that derivative, f prime of theta, that's going to be sine of theta times 0 minus 1 times sine of theta, or times the derivative of sine of theta, which is cosine of theta, and square that denominator, so sine squared theta. And let's look at what happens here. I got negative cosine theta over sine squared theta. And I want to do something similar. I want to just kind of rewrite these and combine them in a way that's going to make it one simple output. So I'm going to rewrite this so that I have negative 1 over sine theta times cosine theta over sine theta. And I'm going to simplify that. So that's negative cosecant theta times cotangent theta. And so now whenever I see that derivative and I see it out of the corner of my eye that I do need to come back and I fix this one, that should have been d theta. So whenever I see the derivative of cosecant of theta, or whatever that variable might be, I know that's going to be negative cosecant cotangent. And that's really going to help me memorize it rather than just doing the quotient rule every single time. So all 4 of these that you see here, all 4 of these derivatives, you're going to want to add it to your arsenal, just like you have sine, the derivative of sine, and the derivative of cosine memorized as well. Now I want to actually put it to use, right? So if I want to find the equation of the normal line, we've got a function and we want to find it when theta equals pi. Okay, so let's start by finding our point of tangency. Where is it touching the graph? So I'm going to find my point of tangency just by finding f of pi. And so that's going to be 3 pi divided by cosine of pi. Okay, and cosine of pi is -1, so I get -3 pi. So I'm going to put that in my back pocket and I'll pull it out later. So now I want to find the slope of the tangent line, but in order to do that, I need that derivative. So f prime of theta, all right, so f prime of theta, that's going to be low, so cosine of theta d high, so times 3, minus high, so 3 theta, d low, so the derivative of cosine, that's negative sine, so negative sine theta, square that denominator, and away we go. All right, and I'm just going to just like rewrite this real fast. That's 3 cosine theta plus 3 theta sine theta, all divided by cosine squared theta. Because I'm going to use that in a second when I find the slope of the tangent line, and I want to make sure that it's as useful as possible, right? Without as many parentheses, take some of those out. That's nice. All right. So if I want to find the slope of the tangent line, in order to do that, I want to find f prime at our value of theta, so f prime of pi. Okay, so that's going to be 3 cosine of pi plus 3 pi times sine of pi, all divided by cosine squared of pi. All right, so 3 cosine of pi, so cosine of pi is -1, so I get -3. Well, right here, sine of pi right here, that actually comes out to be 0. So 0 times 3 pi, so that's going to be plus 0. So I just get -3 right there. And then cosine squared of pi. So cosine of pi again is -1. I square that and I get +1. So this comes out to be -3. That's my slope of the tangent line. Now I have enough information. Oh wait, no I don't, because I want to find the normal line. Don't forget to take this further. That normal line, that slope of the normal line that we need is just a negative reciprocal. So that's going to be +1/3. Now I have enough information to find to write the equation of the normal line. So all I've got to do is go y minus the y value that I found, so +3 pi equals my slope, which is 1/3, times x minus the x value that I'm using, so x minus pi. And that right there is going to be the equation of the normal line. All right, so that's going to finish this part. The next video is actually going to be quite a bit longer because there's so many examples, right? As you're going through all these examples, you really want to make sure that you're writing and that you're saying it to yourself, the quotient rule, every time. All right, the more that you practice it now, the better it's going to be later when we actually have to utilize that quotient rule, especially further into your calculus career. So please make sure that you are doing that and you are working as diligently as possible when you're watching these notes. Of course, if you're confused on any of these topics, please reach out to me. I'm always here to help. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.